Thank you very much for those that are already there. We're going to have this training session online about transport modeling for sustainable urban mobility planning, even in environments with poor and or scarce mobility data. This is part of a series of trainings after the Mobilize Your City SUMP guidelines launch. A few weeks ago, we had a session specifically explaining the guidelines, and then we will have these sessions and two other going through the SUMP cycle. So please, if we could go to the next slide. So this is always a presentation that we're doing using our training materials that you can find online, the catalog that we have. These are training materials that have been developed in partnership with Suez Consulting, and then of course with the support of all our donors. If you want to use the training materials, please get in contact with the Secretariat, and then we will support in the process of delivering these kind of sessions. Next slide, please. Some general notes for the session. So please, in general, make sure that your microphone is muted and that your camera is turned off, because this session will be recorded and then it will be uploaded on our YouTube channel. So if you don't want to appear in the session recording, please make sure that your camera is turned off. And then, of course, if you have a question, you can send it on the chat, preferably to be answered at the end of the session, or raise your hand, and then we will allow you to speak up to ask your questions. So please, next slide. As I was saying, this is a training session, part of our Mastering Mobility series that is focusing on the Sustainable Urban Mobility Plan cycle. And the objectives of this session are mainly two. First one is understand what can be expected from urban mobility modeling, its objectives, nature, methods, and limitations, all framed in sustainable urban mobility planning. And then also provide insights on how to choose the modeling approach best adapted to the context, especially when data is scarce. There is a challenge that we face constantly in cities that are medium-sized and also that have challenges to collect all this data, and maybe they don't have the resources. So next slide, please. For the session, we're gonna go through different sections. We're gonna start with the warm-up exercise. It's gonna be a very interactive session. So we will ask you to contribute to a tool that we will introduce later on. Then we're gonna see where is a transport modeling and what are its main uses. We will also see an overview of different transport planning models, to then see the usual methodology and things not to be missed when you're preparing your transport model for mobility planning. We will also see how to do transport modeling with poor and scarce data. And then finally, we'll have some space for questions and feedback, and then the farewell. Next slide, please. So today, I will be introducing the session. I'm Nicolas Cruz. I'm Sustainable Mobility Expert from the MobiliseYourCity Secretariat based in Brussels. And then our main speaker and the one that will be leading this session, it's Vincent Licher, Director of Suez Consulting Mobilities, who also was involved in the preparation of the material. So Vincent, thank you for being there and for conducting this session today. That I have to say has raised the interest from many people, and we're happy to have a very high participation today on the topic. So next slide, please. And as I was saying, this training session is part of the series that we're having around the Sustainable Urban Mobility Plan cycle after the launch of our Mobilize Your City SUMP guidelines. And I just wanted to mention that the document is on already since a month ago. And this is just a reminder of what's specific about our Mobilize Your City Sustainable Urban Mobility Plans methodology. As you know, this is a methodology that is based on the European guidelines, and we basically follow the same structure, phases and steps. And I just wanted to mention what's different about our methodology at Mobilize Your City. So first one is prepare readiness assessment. So we have a step 0 that the European SUMP guidelines doesn't have. All our sustainable urban mobility plans should have climate change mitigation and adaptation goals. So we really take care of considering projects that reduce emissions and enhance the resilience of the cities where they're planned for. We also try to make the most of innovation and digital technologies potential, and this is especially relevant for the transformation of the paratransit sector. There is a very relevant mode in the cities where we work in. We also establish sustainable mobility observatories for monitoring and evaluation of the plans to make sure that the plans are not stored somewhere, but they are actually being implemented. And then we try to track what's happening with these plans. And then the guidelines are embedded within a robust system of support for cities. So this is the methodology. There is the cornerstone of our methodological support. But then in the next slide, please, Vincent, we see that we're also releasing many topic guides. And the one that we're launching today is this topic guide on transport modeling for mobility planning. This is a topic guide that was released a few weeks ago, and that is based mainly on the content of this training session. So what you're going to see in the topic guide is mainly the same content that you're going to see here in another format. And basically what the topic guide provides is answers to the questions that you can see on the screen. So what is a transport model? Why it is important to develop a transport model, different types of transport models for urban mobility planning, and then finally how to develop a transport model for sustainable urban mobility plans development. So on the chat, you will find the links for the topic guide. And then without more introduction, I give the floor to Vincent Lichert. So thank you, Vincent, for being here, and the floor is yours.
Thank you, Nicolas, and hello, everyone. Welcome to this session. We are going to begin with a warm-up exercise. As Nicolas said, it will be an interactive session as much as possible. So I propose that you join on the Klaxoon platform, and there are different ways to do so. Maybe Ines, you could copy the link in the chat box, so it is easy for the participants to connect on their computer if they wish, or you can copy this address, or you can also connect, if you wish, with your smartphone with the QR code, which is here. I will do that on my side. So I leave you a couple of minutes when you access the platform where you need to give a nickname and then accept the conditions. And that is all. Normally, then you join the platform. Okay, so let's begin. So this is a wall where you can add post-its, And just to begin with, I propose that we all, yes, you click on the plus sign here, and then I'm from Lyon. Just give the, and then you click on the arrow, white and green here, just to see where you come from, where we all come from. Oh, many French people, Belgium. Oh, very nice. As you see, you can choose also the color of the post-it if you wish. Various options. That's it. Okay, I see we are coming from various countries and continents. Welcome to all. Now I propose a little more complicated question linked to our topic today. And if you, I see other cities coming. So, yep, let's switch. Normally you follow me on the screen, and I would like us to make some thoughts of what has changed regarding mobility, behavior, and flows in my city, in your city, over the last 20 years. Not in terms of transport networks or supply. Oops, Peshawar. Good. We can maybe there. But in terms of behavior, main changes in terms of mode choice, in terms of distance, in terms of trip purpose, maybe, or the way people choose, the way they move. What would you say if you compare with the situation in the early 2000s? Short sentences or a couple of words. Okay, less use of car because of traffic, more cars, but less driving, still a lot of parking. Urban freight, more mass public transport offer, more biking. Okay, many things on active modes. Okay. Private vehicles. Increase of distance. Okay, we see a lot of things regarding transport modes, but also this increase of distance. Reduction of speed. Access to transport modes, affordability. Okay, impact of the costs. Okay, let's focus there on the behavior, not yet on the cause or the factors, the transport factors. Okay, good. Thank you. And now with these changes in mind, next question is to think of the causes of these changes. What are the main causes of these changes? Urban development, new technologies, transport, supply evolutions, sociologic impacts. Okay, events like pandemics. Okay. I group here urban factors, here more transport factors and transport policies. Yes, home office, of course. Okay, we see clearly different kind of factors. Transport networks, the urban factors, economic factors. Okay, transport policies. Yes, environmental concerns. Okay. So this is interesting because it helps us think of what happened previously and the kind of things that could happen in the future, and logically things that should be in our models if we are to forecast or guess what will happen in the future. We will come back to Klaxoon later on, so you can keep the window open. We will come back to the same window with other exercises. Thank you. So causes of mobility changes might be grouped in categories. Maybe urban development with the evolutions of population, employment, densities, urban extension, urban shape. Also socioeconomic factors, evolutions of income, vehicle ownership, cost of fuel or energy. Societal evolutions of the household size and composition, changes in women activities, development of leisure, working from home, and so on. And transport factors that we could also say technological factors. And all these causes are part of systems of cause and effects that could be represented by these kind of flowcharts. We can say, okay, there is an increase in population, so more trips, but also maybe more trips per person because of the development of leisure, for example, possibly partly linked with increase of income. So it results in more trips. And we have also the urban sprawl, which results in longer trips, maybe a higher car ownership linked with the road network development. And there is relation of cause and effects both ways sometimes, for example, between the urban sprawl and the development of the road network. And we could maybe put a double arrow here also. And maybe hopefully in the same time there has been a public transport improvement. So what is the results? More or less traffic, And with the development of the road network and of the public transport ridership, more or less congestion, it might depend. So we see that, and it is only a small part of all the factors. So we see that we are tackling a very complicated system, but this is already a model, and the base of every model is something like that. An image of cause and effects regarding mobility and an interpretation of reality. So what is transport modeling and what are its main uses? If we try a definition in the context of this training, transport modeling linked to transport planning, we could say it is methods and tools to estimate urban trips, meaning the number of persons moving in a city, possibly by period of time, origins and destinations, mode of transport, trip purpose, maybe on a specific transport mode or infrastructure. In situations that cannot be directly observed, otherwise we would do surveys and traffic counts. So it's generally in the future situation, or with to test changes in demographic, economic situations, or in the transport system or policies, to be used for urban mobility management or transport planning processes. For example, urban mobility plans, transport system design, or traffic management plans. Transport modeling can have various objectives. The first one would be forecasting transport needs to develop mobility policies. And for that, what we will need mostly is the number of trips from zone to zone, maybe for the full days, to see in the future, for example, 2035, and global evolutions. Transport modeling might be used also to dimension transport services and infrastructures. So the question would be there more, how many vehicles or passenger per hour and per direction on a specific infrastructure. A third kind of objectives would be to evaluate transport policies. For that, the outputs that will be wanted are the number of passengers per day or per year, but also mode shifts, trip time savings, the number of vehicle kilometers that could have been removed from the road system, the evolution of pollutants emissions and greenhouse gas emissions, things like that, and energy consumption and so on. And fourth kind of objectives for transport modeling would be to reconstruct past or existing situation when data is missing. So modeling is not only for the future. Some examples of the use of transport models. Sometimes it is used for what we call prospective diagnosis, meaning trying to find what would happen in a do-nothing scenario. For example, here it's an exercise we made in Hyderabad in India, trying to extrapolate previous trends just to see and to show what would happen if nothing was done. And where it would lead. This was based on a very simplified model, actually. It's just a spreadsheet and extrapolating the trends. But it's already a model. In Dakar, for the Sustainable Urban Mobility Plan, we made something quite similar, but in combination with a detailed model that you see the image on the right. Here we made first this simulation of the potential evolution if nothing was done, and to show the challenges and the increase of motorized trips, for example. And then another model could show what would happen, and everything that is black means that there is too much traffic, and that it cannot work. An example where it was used to test bus reorganization around the project of bus rapid transit in Agadir. Then it's to evaluate the potential ridership of the bus rapid transit based on the ridership of existing bus lines. And I will come back to this example and the methodology, but it's also a situation where a model can be useful. Here, for the study of the bus rapid transit in Yaoundé, Cameroon, a full-fledged transport model based on the household mobility survey to evaluate the future ridership of this project along the line, and boardings and lightings on stations, and the load along the line. Another example in Casablanca, with the use of a model to evaluate fare policies, evolution in the fare policy, with the use of a public transport model combined with a financial model. Okay, different examples to show the variety of the situation where a model can be used. So what do we intend to model? We need to model all factors, ideally, impacting urban mobility. And we saw already the different kind of factors that are again listed here. Many factors, and obviously not all possible to be modeled, because we speak of something quite complicated. It is human behavior. And it's probably much easier to forecast the way of how water would circulate in tubes in a city. But we speak of human behavior, and if we think of ourselves, how we choose the way we move in our city every day, and change from one day to another, we can see how it is complicated. A little sketch that I love to explain in detail what is at stake with modeling. We have observed situation, present or past situation, for which we can make surveys and see what happens for the situation of transport in a city. And then we have a considered situation that we would like to simulate for the future, or we would like to make a change. Sometimes, if it's a small change, we can test it in real life and see if it works or not. Maybe if it's a new bus line. But if it's a big change, we cannot test it. But so we cannot go directly from the observed situation to the considered situation. So this is where models can be useful. We go from the real world, represented by this apple, and we need to transfer to the world of models, which is a simplified world, by an operation called calibration. And the model cannot represent all the complexity of the reality, even the best model in the world, because we speak of human behavior in a very complex system. So it is essential to understand that any model include only a part of the dimensions of reality, and it is very important to understand and to choose what would be the projection and on which way we want to look at reality, depending of the issue we have to solve, or the use of the model we want to depending on how the model is to be used. So the model is a simplified representation of reality. But what is good with it is that in this world we can go make simulations and go to the considered situation and see what would be the change of the situation, what would be the impact of these scenarios. But the mistake would be to say, okay, this is the answer, this is the future reality, the future will be like that. No, of course, we need to come back to the real world, and we need to understand that the model do not give you an image of the real world, but clues and tools to help us understand what will happen in the real world. But we need to come back to the real world by a process of interpretation. We need to reconstruct the dimensions that are not included in the model by a process of reconstructing questioning what will happen in the other dimensions, and various things might happen. So I am French, as you might guess. So there are different ways of interpreting the same model results, and to be able to make this interpretation, it is essential to understand how the calibration has been made, meaning what are the dimensions that are included in the model and what are the dimensions that are not included. Saying that shows that a model is something quite complicated, and that you cannot interpret correctly the results if you don't know how the model was made. Another consequence is that if you are the model practitioner, you should not, from my opinion, show that to the decision makers. This has no interest for them, but you should use your tool to say, what does it teach me on reality? And even including this question of uncertainty on what it teaches about reality. So some messages to keep in mind. There is no universal model because the reality is too complex. You cannot dream of a transport model that will answer all questions, that will enable testing any scenario. A model of human behavior is always partial. There are only a part of the dimensions. So we don't make forecasts. We speak of forecasts generally, but we don't make forecasts. Maybe for the weather, there might be forecasts for the coming days, but not for transport planning. We make simulations based on assumptions and a simplified representation of reality. It's not a crystal ball. We understand that results interpretation is key in the process, and it is only possible if the model is not a black box. So it is very important that the nature and calibration of the model is clear. And it is recommended to combine different approaches because we need to reconstruct the dimensions that are not included in the model. So maybe we cannot offer different models, but maybe we can complement the model with simplified calculations, feedback from experience, common sense, which is in any situation very, very useful, even if common sense might be wrong, but still we need to be confident also in what we understand. Mobility is something that is quite easy to apprehend because it's part of our daily life. So all these ways to cross-check the results and include factors that could not be modeled. Sometimes we are questioned about the confidence interval of our modeling results. And if we answer honestly, the confidence interval is huge and the uncertainty is huge. And if we show that, probably the people funding the models will say, okay, no, we don't pay anymore for the model. But still, well-used models are necessary and useful. But actually, uncertainty is everywhere in the process. And first, it is present in the picture of the present situation. We tend to, we calibrate a model on an observed situation, on surveys, but it might not be reasonable to try to represent, for example, traffic figures by 10% or 5% or 3%, while maybe the traffic on the same road varies by 30% from one day to another. This is what I mean when I say the reality of mobility itself is highly variable, and the best surveys give only a screenshot. It's a moving reality, the mobility in a city. So there is uncertainty already in the picture of the present situation. And then, of course, the assumption for the future, the assumption of the evolution of the city, of the global context, and of the scenario itself. Maybe I will test a BRT, but in the end, the bus reorganization around the BRT will not be at all what was planned. And there are so many factors like that. Often there is a confusion between the model and the software. And when you say, okay, I'm working on models, oh, what model do you use? Is it Visum? Is it Cube? There is the model, which is the approach, the methods, the data that are used, and the software that might be used to implement the model. But as I said, the chart that I showed at the beginning with the arrows is already a model, and there is no software except a PowerPoint. The software might be Excel. Okay, there is a software is often useful because we speak of a complicated system, but there is it is important to see the difference. And there are several specialized software for the representation, the coding of transport networks, and the simulation of route choices, called assignment. And these software include toolboxes to model mobility choices, moving or not, to go where, by which mode of transport. Transport modeling usually uses software tools, but it's not because I have a good software that I can make a good model. Transport modeling is widely an issue of know-how, experience, capacity to adapt the method to the objectives of a specific project and to the available data. I'm not selling any software. I have no interest in anyone. There are quite a lot. I think I list with these 4 ones, probably I would say 80% of the models of the these are the software that are used for maybe 80% of the models in the world. Probably Visum, made by PTV from Germany. Cube, which has a long history and which has merged previous softwares such as TRIPS, MinUTP, Twanplan, and a long history. EMI, the Canadian one, and Transcad from the USA also. Okay, they have their specificities, but globally they give the same kind of functionalities. Now let's go to the next section where we will speak of the different transport planning models, not softwares. And these categories, I would not say that they are something universal. There might be different ways of classifying the methodologies, the model methodologies, but this will give an overview. First, there are what we call strategic or macro models, generally based on spreadsheets, used either alone or in combination with detailed models. So I show previously examples from Hyderabad or Dakar. And they are essential for cross-checks with the full picture based on global or large zones, indicators of population, mobility, vehicle ownership, etc., and explicitation of assumptions. So it's really macro approaches. Maybe well, in Dakar for the full city we had only 4 zones in this approach. And we considered the evolution of the main ratios, such as mobility per person, such as car ownership, and so on, to make an exploration of the future. Then other kind of models that will not usually be based on a specialized software, but which are focused on one mode only, road traffic only or public transport only. And it's a good method, actually, for many cases, pragmatic and robust solution. For example, for road traffic studies, when model shifts can be neglected, or for public transport studies, when you can evaluate the evolution of the demand through elasticity ratios. So compared to multimodal model that we will discuss afterwards, you have a much easier calibration and implementation, less data required, and more stable and reliable results when the context is not changing too much. And often when for example, when you create a mass transit line, most of the future ridership of this mass transit line is made of people that are already in public transport, in buses or paratransit and so on. So maybe base your model on this, the knowledge of these trips only is enough. And an example of this approach we made for Casablanca in the transport fare policy study I already mentioned. So we used Visu, the software from PTV. We code the network with the tramways, the buses, and collective taxi lines. We made origin-destination surveys in all these modes, and also used the ticketing data from the tramway to create a zone-to-zone trip matrix for the present situation. We calibrated the assignment on the networks on ridership counts to be sure that we represented globally, approximately correctly, the loads of the tramways, of the bus lines, and so on. Then we estimated a do-nothing matrix for the future year based on the evolution of the population and employment and global mobility ratios based on the strategic approach as the ones we just saw. And then with that, for these future situations, we were able to test scenarios combining an evolution of the public transport networks and new fare policies, for example, with an integration of bus and tramway fares. And combining, yes, different elements of trip times, fares, and comfort. Another kind of monomodal approaches without the use of modeling software. When you work on a specified corridor, and when you, for example, here in Agadir, for the bus rapid transit, we had the idea that most of the future ridership of the BRT will come from the people that are already in the buses, but there were various ways of reorganizing the bus networks. So we created a tool just to be able to simulate how, depending on how we will change the bus network, as a complement of the BRT. How many people will transfer to the BRT, on which sections, etc., depending on the scenario. It was a simplified way on Excel, but it allowed the test of many scenarios and very interactive way to show the impact of on the BRT ridership. So these approaches can be good. I show you all that so you have in mind that we should not rush to the most complicated methods. It depends on what are the objectives, what data you have, what time you have, what budget you have. And then there are multimodal models. So the ambition of modeling the global mobility behavior with all modes, a large part of the phenomena. And of course, these are very interesting models because they give extensive outputs, possibilities of testing a lot of things, but they requires a lot of data. Calibration is complex, and it's much more technical and less stable results than previous approaches. So generally, ideally, they are based on household survey, where you ask people what trips they made the previous day, and you combine that with the personal data. It requires zonal data and forecasts on population and employment with the characteristics that are characterizing their mobility behavior. There are specific and highly specialized calibration methods, mostly to calibrate the choice of the mode of transport. With that, you can reconstruct future origin-destination matrices through methods implemented on spreadsheet or inside the modeling software. And that the networks model and the assignment of the origin-destination matrices on the networks are made with the modeling software. And there are an extensive variety of results, graphical and numerical, production of inputs for socioeconomic evaluation and so on. So this remains the top approach, but that does not mean that it is the best one in any case. Other approaches are related to what are called stated preference surveys or models, and I call that special purpose models. In the multimodal model, you try to represent more or less the full city and all the reality with a tool that is supposed to be able to test a number of scenarios. But you can also say, okay, I have one project, and I just need to focus on this question of the impact of this project. And a way to do it is to make stated preference surveys, which consist in asking people what they would do, which mode they would choose, for example, in certain situation, but so that it is reliable. Special techniques are to be used to be sure that, well, to make sure that you ask people to project themselves in situation close enough to their real experience, so their answer sorry, is reliable. And from these surveys, you can derive econometric models that can be used to calibrate a classical multimodal model, or that can be used alone. These methods are not do not come from the mobility and transport sector. They come from marketing technologies, actually. So this method can be very relevant when the goal is to focus on a specific project, all the more to test the introduction of something totally new in the context, because you cannot calibrate a complicated model on something that has not been observed. So these kind of surveys is a way to observe something that you cannot observe in reality. So there might be no network coding, no matrices, and maybe just a model based of the sample of surveyed people, and to see how these people would react to different scenarios, and then you extrapolate to the full population. And just to mention that there are also micro models or dynamic models based on mobiles, meaning that every vehicle or every pedestrian is modeled individually, but these models are less for strategic planning and more for operational purpose. So, and other kind of softwares are used. So it's less relevant for our topic today, but it is interesting to have that in mind. And there are also mixed approaches between the static, so-called static approaches that we saw before, and these dynamic models. Okay, now the question of data that is required. Again, this table is not something absolute, but to give an idea of what would be needed for the main categories: macro, strategic model, monomodal model, or multimodal models. You will need data for population, employment, and so on. So by large zones for strategic approach, present and forecasts. By small zones for the monomodal or multimodal models. And with characteristics of population that can be quite simplified for the monomodal approach, but that must be more comprehensive for the multimodal approach. Socioeconomic data, potentially many data could be useful. In the strategic approach, you will try to use where you have big zones, simplified vision of things, but you try to include many factors: vehicle ownership, evolutions of income, energy costs, and so on. In the multimodal approach, vehicle ownership is certainly the minimum. That does not mean that these data are not useful. Data about the trips. So global ratios could be enough for the strategic approach. Public transport ridership, usually you have you can have counts of the number of passengers in the public transport lines. For the monomodal approach, modal counts, traffic counts, or counts in public transport lines. Origin destination survey, mostly for public transport approach, and stated preference survey if a new mode to be introduced. And for the multimodal models, the best source is the household survey, because it is the only approach that will give you a full view of mobility behavior. Possibly stated preference survey also from mode choice calibration, traffic counts, public transport ridership. And then data for transport networks with only global ratios, such as public transport vehicle kilometers for the strategic approach. And for the other methods, if you need to describe in detail the networks, you will need for the roads, the structure of the network, capacities, number of vehicles per hour for every link's length, and max speed, and so on. And for public transport, obviously, the lines, the stops, the headways, the station-to-station times. Agreed to help the choice of the method, but again, it's not absolute. It has to be adapted. For sustainable mobility plan, at a minimum, I would say a strategic model, ideally a multimodal model. For local traffic plan, meaning car traffic, assignment software, and possibly a dynamic model. Global traffic plan, meaning at metropolis scale, an assignment software or a monomodal road model could be enough. For a road project, it could be maybe just a reassignment methods based on traffic counts on the existing roads, or monomodal or multimodal if significant mode shifts are expected. For public transport reorganization, maybe just the reassignment methods that we saw in for Agadir, for example, if the reorganization is limited, or a monomodal model could be enough. Mass transit network planning, at least a monomodal model or possibly a multimodal model. Public transport or mass transit line design, again, reassignment method could be enough in certain cases. And then monomodal public transport or multimodal if significant mode shifts are expected. Another example for public transport fare or toll road, more oriented on financial study. A monomodal approach could be enough, but multimodal or stated preference based could be a good solution. And then I think it's the last slide for this section, just to show how and where the modeling find its place inside the SUMP cycle. So the Sustainable Urban Mobility Plan cycle. The start is the preparation and analysis phase, and during this this stage, it's the time where you can have the surveys and the development of external assumptions, such as the future evolution of the city or of the fuel cost and so on. The model preparation and the test of do-nothing scenarios, which are very useful for the diagnosis. Then in phase 2, vision, goal setting, and scenario building, the model can be used to test the scenarios and their impacts on mobility. The third phase is measure planning. And there, the model can be used to test refined scenarios and to finalize the economic and financial evaluations. And in the last phase of implementation and monitoring, the model can still be used to update the simulation with the refined assumptions, a better view of what will be eventually implemented. So we see that the model is actually present in each phase of the SUMP cycle, and is a tool that is useful to have with you all along. So let's go back to Klaxoon. Maybe we can copy again the link in the chat. But if you are still connected, you can just go back to the previous exercise, and now I will propose you just some questions. You have to vote for 5 questions. What modeling approach would you choose in the following cases? So normally you see the questions, and you can click on the method that you would favor. You need to click to participate, probably. I leave you a couple of minutes. There is no single and possible answer. Do not think too long. I wait 1 more minute. Okay, let's see the results. So the first question was, what modeling approach would you choose in the following case? Developing a sustainable urban mobility plan at city scale in a 50,000 inhabitants sub-Saharan city. Okay, so many different choices. 43% on, well, most of people voted for the strategic approach. Probably I would have voted the same. Because probably in this context, I will not have a lot of data. Monomodal approach, I'm not sure it's adapted to sustainable urban mobility plan, which by nature is multimodal. Okay, good. Second case, changing an existing major bus line into a bus rapid transit. So, okay, most of people have voted monomodal and possibly strategic. Okay. Yes, monomodal might be a good approach if it's changing an existing major bus line into a bus rapid transit, meaning that probably most of the future ridership is already, well, we can consider at least that the ridership of the existing line is a representation of the potential of the BRT. Creating a non-motorized transportation corridor in a medium density neighborhood of a big city in India. This is not easy because non-motorized transportation is generally not very well taken into account in models. So maybe stated preference is a good choice, yes, or a multimodal approach. Nobody voted for a strategic approach, but still thinking of the potential of non-motorized transportation based on global ratios could be a way to do it. And again, you can cross various methods just to cross-check and improve the reliability of the methods. Elaborating a fair policy on an existing public transport network. Okay, stated preference, assignment, or monomodal are probably good choices. And the last one, promoting walkability in a city center through a new traffic management plan. So it depends on how you interpret the issue. I would probably think that the main issue there is the impact on the traffic, and that maybe, yes, it's less, the issue is not to model the pedestrian flows, but most the traffic. And then a dynamic model might be a good idea, or possibly a monomodal approach on the road traffic. Okay, thank you. We will come back to Klaxoon again in a moment. So let's go to next section. Next section on the usual methodology and things not to be missed. There is a common approach called the four-step model. The principle is to consider that mobility choices are made by steps in a certain order. Again, it's a very simplified way of approaching things, but it's been used for decades and showed that it is a powerful way of representing reality, even if it can be considered as very simplified. So the idea is that when you make your choices of mobility, the first question you ask yourself is, will I go out of my home or not? Will I move or not? It is what we call the generation step. And it's the way to evaluate the number of trips emitted or attracted by each zone. It can be maybe just to multiply the number of inhabitants by an average number of trips per day per person, for example. And then once I have decided to go out, the idea is that now I ask myself, where can I go? So this phase of distribution. It's the way to distribute the flows by origin and destination zones. Or another way to put it is that you need to construct a flow matrix. Generation step is a way to estimate the margins of the matrix, and then the distribution stage is a way to fill the cells of the matrix based on the margins. And then when I have chosen to go out of my home and to go to this other place, the next question is by which mode of transport? So this is the modal choice and the way to distribute the origin destination flows by modes. Of course, in the reality, it's much more complex. I probably, if I have no modal option, I will not go out. Probably I choose also my destination according to the transport modes available. It is a simplified way of representing things. This is preferably done for a full day, or at least when we speak of transport planning, because it is more stable than just estimating the number of trips generated for a peak period, for example. And then at the end of these three steps, I have matrices by origin destination matrices by modes that I can assign on the networks to represent the routes for every origin destination, to evaluate what would be the load of each segment of the transport network. And this must be done for a specific period of time, generally peak hour, at least if transport capacity is at stake. Because clearly for the car traffic, for example, the choice of the route is impacted by the congestion. So the assignment, well, my route is impacted by the choices of the other users. So it is linked to the capacity of the network on a certain amount of time. So between the modal choice and the assignment, there might be the need for an additional step, which is a conversion to peak hour. From daily matrices, I need to derive peak period matrix. Some comments, networks and route choices. So the assignment step is relatively easy to model. This is what the softwares do best. Even if we could question the way they represent the choice of the routes, of the itineraries, generally by minimization of trip times or trip costs, or a combination of time and costs through generalized costs. But maybe the way we will choose our routes in the future will change all the more as activities are developing along the way with mobile internet and so on. But modeling mobility choices, so the first three steps, generation, distribution, model choice, is much more complex and must almost be designed case by case. And for that, again, the software gives tools for that, but you need to construct yourself your model. Usual methods do not include feedbacks from transport supply and transport demand. It is clear that even the generation, the number of, the mobility of people depend on the transport networks. If the transport networks is bad, people will move less. And this feedback is generally not included in models. Intermodal trips combining private and public modes are generally poorly modeled. The kind of trips where I take my car or my motorbike to go to a public transport station to take public transport. And the sequential character of the four-step model is not well adapted when there are significant modifications of the context. So just an example to illustrate that. For example, we have a city and trips coming from outside with 1,000 trips and 20% in public transport, so meaning 200 trips in public transport, let's say from a specific zone, for example. And then I create a toll for a congestion charge for in the city, and this will impact the global cost, generalized cost of coming into the city. So at the distribution step, the number of trips coming in from the outside inside the city will be lower, for example, 600 trips, and the model choice for public transport will increase, but in many cases, actually, the model choice model is less flexible than the distribution one, and in the end you end with less public transport trips than in the first situation because of the sequential character of the model, which is not logical, because the congestion charge would impact only the cars and not the public transport. Okay, just a small example to help understand what the kind of problems that arise with the four-step model. In many contexts, we have to include informal transport. When informal transport is structured by lines, it can be considered as public transport and coded like that. And the choice between formal and informal public transport can be modeled within the assignment stage. And of course, it is important to include the question of the fares. And then when informal transport is without fixed lines, such as collective taxis, but with no lines, then the best is to code these modes as private vehicles with specific costs, specific access times, and access rules. But it is true that the models have been constructed in mostly in northern countries where there is no informal transport or few informal transport. So there are these modes are not well taken into account in the traditional approaches. Something about the role and objectives of calibration. Of course, a model needs to be validated to attest its capacity to represent reality. However, we know that transport models are always a partial representation of reality. And as we already said, the reality of mobility patterns in a city is moving, and it's something that is never fully known. And another problem is that generally the model is calibrated on a situation, on a specific year, on a screenshot of the situation, while they are actually used to model the evolutions between different years. And to give an image, it's like studying the gallop of a horse based on a photo. It's not the best way. Normally, we should calibrate a model on the evolutions between two past situations, which is much more complex. That means that we will need, for example, to have a full set of data for 15 years ago and for last year, and then to see a model that is able to reconstruct the past evolutions. But we never do that. We say, okay, if my model reconstructs the past year, then it will be able to reconstruct the evolutions for the future. Actually, this is not logical. And also because, well, another problem is that models are often used to test situations and transport systems that have not been observed, at least in comparable contexts. So how can I model something I have not observed? We have spoken of stated preference methods before. So all that, not to say that models are not useful and so on, but to give us a global view and an understanding that calibration must be made and judged in view of the model scope, its objectives, the consistency of the results. But it's not a question of 2% or 3%. This is not what we should focus on. And then last slide after another exercise. The most important stages of the model runs are before and after. Modeling is generally focused on calibration and simulations, but major parts of the process are before and after that. Before, because some assumptions that are essential in the results are not questioned. Future distribution of population, jobs, or trip generators, individual daily mobility rates, things like that might be not questioned while they have essential impact on the results. Also, models never include all factors impacting mobility. It means that there are implicit assumptions. If a parameter is not included in a model, it means that by default you consider that it doesn't change. And examples are stability of fuel costs, which is certainly not true in the real life. Stability of transport mode perception, of climate impacts, of security context, of the evolution of the age pyramid, or things like that. Okay, maybe I cannot include all that in the model, but if it's not in the model, I need to have in mind during the interpretation stage that probably these factors could impact the results. And so we need to have that in mind and possibly to analyze and at least qualitatively the potential impacts of these factors. And then after, again, the importance of the interpretation of the results, the idea that the model is a good way to help thinking, but not to replace thinking. The model is not thinking in our place. I don't know if with artificial intelligence in the future there will be other kinds of models that could think at our place, but I think we still need to have to use our brain as the best tool. Post-treatment of results are mandatory before presenting them for decision making. Never present that. You need to present these interpreted results. Okay, we are approaching the end of this session, and I would like to propose you a third exercise. Go again on Klaxoon. With 3 parts. The idea is to explore the 4 steps according to our own experience. We will explore the three first steps, actually, just to save time. But just to think of how we behave ourselves and what it teaches us about the way we could model these phenomena. So first, two questions on generation. How many trips? A trip meaning, okay, going from a purpose A, for example, home, to purpose B, for example, work or shopping or visiting, so on. Did you make yesterday? So if you go to work and come back, it's 2 trips. And then how variable is it on weekdays? Just a way of appreciating that. Is it highly variable or very stable? Still 30 seconds. Okay, 10 seconds. Let's look at the results. How many trips purpose A to purpose B did you make yesterday? Okay, a majority of 2 trips, and then 4 trips, because, okay, it shows that trips mostly work with to and from return trips. 10% 6 trips. Okay, I mean, okay, one loop, 2 loop, 3 loops. Okay, interesting. And then how variable is it on weekdays? Okay, the average is 3. With 20% of people saying that it is highly variable, 40% very variable, so only 15% thinking that it is very stable. So it's another way to see that we are confronted to a moving reality. Okay, fine. We go now to the. I need to launch it. Same principle with 2 questions on distribution. Among your daily destinations, what is the proportion of places where you go at least once a week, every week? And think of the places where you buy most of your food and rank the criteria for choosing the place. Okay, the second one is a little maybe longer to answer. You can rank just moving the proposition up and down from the left, taking them by the left. 1 more minute. Ten seconds. Sorry for the pressure. Okay, let's look at the results. What is the proportion of places where you go at least every week? So about 75%, about 50%. Okay. So we understand that a lot of your destinations are very regular. Yes, and the number of, well, less than 20% still, okay, no, 0%, 5%, about 25%. So we see that our destinations are quite usual. And then ranking the criteria to choose the place where you buy your food. Okay, so this is, I think the way it is ranked on average. Quality of the shop first, distance from your home, or well, meaning from your home or work. Criteria of time. Okay, the choice, access of public transport is less by road, availability of parking. Okay, so what does it mean? That means that if in our distribution model, maybe we should have kind of characterization of the zones to represent correctly the shopping trips. That will be eventually not so dependent of access by road or public transport. Okay, and then let's go to the questions about model choice. Two questions. Do you consider having choice in the choice of your transport mode to go to work? And again, rank the criteria that make you choose your transport mode to go to work. I will leave a little less time for this one because we are running 5 minutes late on the schedule. So let's keep still 30 seconds. Okay, 5 seconds, and I stop the poll. So a large majority of the voters estimate that they have choice in the transport mode, and only 17% think they don't have choice. And now the criteria of choosing the transport mode. Time comes the first one, reliability and convenience, flexibility. And the least ones are safety, possible activities during the trip, or comfort. It's interesting to see environmental impact that is quite high in the hierarchy, the same level than the cost. And probably that's something that has evolved recently, and it's good, of course. Okay. So now last section, quite short before the end, how to do transport modeling with poor or scarce data. As Nicolas was saying at the beginning, it's a situation that we encounter very commonly. So the first answer I would say is focusing on the objectives. It's kind of value analysis, I would say, on the model. If we don't have the data for a full-fledged model, let's make a model adapted to the available data. So what do we really need to know? Annual ridership, maximum load, trip time savings. We might not need to have the full picture of mobility in the city. What do we really need to know? And do we need precise results, or can we do with orders of magnitudes? And it might be enough to dimension the transport system, choose a technology, or say that if the road needs 2 lanes or 4 lanes or 6 lanes. Can some rough calculations normally used for cross-checks replace model results if there is no better options? And yes, possibly. For example, evaluating population through density factors, trip emissions through mobility factors, mode shares from comparable situation and available counts. You can reconstruct a present situation with some data, an image of the actual situation that could not be so wrong, even with poor data. But maybe a good survey is more important than the model itself. Second, data that can be used when you have known, because actually you always have data. For zonal population, employment and trip generators, you can use aerial photographs, density estimates, type of housing. That could be tools to estimate population per zone. Online mapping, such as Google or OpenStreetMap or so, for trip generators and many data. Site visits, of course. Employment, the number of jobs by zone is most complex for many reasons. So sometimes that can be done in some contexts if you have data for big companies, administrations that you can locate, and then you can have an idea of the orders of magnitude of the total number of jobs, and consider that apart from these big employers, the rest of the jobs are distributed relatively in proportion to the population. Can be a way, for example. Transport networks can be approached by aerial photographs also for the road network, online mapping and data, site visits, and then exchange with the operators for public transport. And for the trips, mobility or motorized mobility ratios from comparable contexts, traffic passenger counts. The number of vehicles might be known because they are registered, and from the number of vehicles, private cars, the number of buses, etc., you can derive estimates of the number of trips, because you would say, okay, every bus probably transports this number of hundreds of people every day, and you can say, okay, people that have car probably use them, so can help to make an estimate of the number of trips by car and things like that. Third, model can be used to reconstruct present situation and to complement data, and to reconstruct missing data. We've reconstructed population and employment zonal data, assume mobility ratios, you can make the trip generation. You say, okay, probably on average, this number of trips per person derived from other cities where I have surveys. The distribution model can be estimated in view on the average trip distance that results from the model, and you can have maybe a gut feeling of what should be the average trip distance if you know better data. For transport modes, possibly a pre-calibrated model from another city, but that might be more hazardous than for distribution because it's more site relative. So a solution could be to have a trip generation made by modes based on accessibility levels from each zone and each mode, and an estimate of the number of trips by public transport made on average by people, and making the generation mode by mode. And maybe if you don't have a lot of data, a monomodal approach is more reasonable than multimodal approach. So there are always ways of progressing, even if you have few data. Of course, it's important to make possible efforts on the data connection, but still. And then last message, importance of macro approaches. Our models often look like things like that. They have to be complemented or replaced by models that could be more that something like that. It could be an image of the strategic approach. Thank you. There is a final quiz. I don't know, Nicola, if we still have time. Normally we have 5 minutes left, but okay, maybe we should we keep them for questions?
Yes, I think it's fine if the participants want to answer the questions from the quiz, just like to refresh a bit all the information that you just explained. And in the meanwhile, we can see if there are some questions that you could answer while participants answer the quiz. I invite everyone to include your questions on the chat. And then I will ask it to Vincent. Otherwise, you can raise your hand and then turn your camera on and speak up. While we wait for the questions, Vincent, I have a question myself that I would like to ask, and is because I see that the transport modeling is very oriented for motorized transport, so private vehicles and public transport and maybe paratransit. But another big part of what we do at Mobilize Your City is also active modes of transport. One part of the question is, do we want to model walking and cycling? And then the second part is, if we do, what's the best approach to include these modes into transport modeling?
Yes, I think it's very important to include that in our methods, and methods have to be developed for that. I think it has been very poorly addressed in the past in the modeling exercises. So thinking of what are the criteria that for which people choose walking or cycling. It has long been considered as a default mode. People walk because they have no other choice or things like that, while actually it's not the case. And cycling is a huge challenge. So more and more methods are developed to include them in multimodal approaches or strategic approaches, but there is a need for research and development in that. This is all I can say.
Okay, thank you for the answer. We have another one. Based on your experience, are the mobility patterns different from one country to another?
Well, yes, of course, the universe of modes and can be very different from of available modes. I mean, can be very different from one country to another. Like auto rickshaw is very important in India. That might not be present everywhere. And then sociologic factors. Even if we are going more and more to a global world with maybe less differences in the behaviors between countries, but still there are cultural factors, socioeconomic factors that are very different. So, well, I think a lot of efforts should be made on understanding why people make their choice before trying to model these choices. Often we go too fast to the tool, to the calculations, to the formulas. But the first thing is to understand what happens, and then from that, maybe even without a model, we can better forecast what will happen in the future, and then it can give clues to maybe very limited models that could be made, or to adaptations that could be made. But it's a question of culture. There is, I have often observed in my career that there is a kind of fascination for models, and there is a kind of religion for models, and often me as a consultant, I am pushed to make a model and spend a lot of money and efforts on a model, while I would like to spend more time on understanding the present patterns and past evolutions.
Okay, thank you very much for that answer. And I think that's the core of this topic, and what you were mentioning, that there is a trade-off between actually having a model and replicating what's happening in reality with this behavior that is not easy to model. So thank you very much for the presentation, Vincent. I think it was very informative. I would like to invite all the participants to check out the topic guide on this topic that we just released, Mobilize Your City, so you will have more detailed explanation. Just to clarify, we will invite a follow-up email to all of you who participated in this session, and then you will get the slides, of course, and the recording. Because I saw that there are many French speakers that joined today, I would like to invite you to join the session on the same topic. Vincent is also going to be the speaker for that session next Tuesday, but it will be held in French. So if you want to revisit the topic but in French, you could do so. Ines shared the link on the chat, and so you will find it there. And then I would like to invite you also to the other training sessions that are coming up in English. One for measure selection to scenario development in the context of preparing a sustainable urban mobility plan. And then also another one about innovative mass transit options, so understanding mass transit options and how to combine it with mobility as a service dimensions. So thank you very much, all of you, and see you soon, hopefully.